It's my honor and pleasure to introduce Dr. Jeffrey Chase. Dr. Chase is a professor of computer science at Duke University in Durham. His research with Duke's Network and Internet Computing Lab deals with efficient and reliable sharing of information and resources in computer networks ranging from clusters to the global internet. He has over 80 technical publications that he has published. He's referred to in conferences and journals on topics including network storage, I/O prefetching, end system networking, active storage, utility computing, internet content distribution, massive data computing, and automated management of large-scale server infrastructure. So Jeff does a lot of different things. He's involved in everything from the bits and bytes transmitting to the cloud. He has served on program committees for leading technical conferences in operating systems, distributed computing, file and storage technologies, and web content delivery. He's an alumnus of Dartmouth. He received his PhD in computer science from the University of Washington. He has private sector experience, spent 7 years as a senior software engineer at Digital Equipment, working primarily on the Unix kernel, developer in the areas of file systems and networking. Needless to say, he's decorated, and he's done a lot of things. This is just his volunteer activities for the last 5 years. So Jeff is someone who has impressed us all with not just his brain power, but also his willingness to share that brain power forever. If there was ever a Metcalfe's law of sharing, of the value of sharing information, Jeff would be the model of that, probably that law, because it's probably it's way beyond squared. It's probably to the 10th or so, the value that people have gained from Jeff. So Jeff, thank you for joining us today, and the floor is yours.
Thank you very much for that introduction. It's a privilege to be here in this company as the token academic at the end of the day. Let's see, how do we... There we go. So this is, I think, the time of the day when we start to repeat ourselves, because I was going to reveal to you all that actually Duke invented the internet, to those who have forgotten, or at least, as Henry mentioned, that the Usenet actually started at Duke. Actually, he said it was UNC, some students from UNC and Duke. We like to say from Duke and UNC. And in fact, that machine that was running some of the Usenet services at Duke was just shut off just a couple of years ago. But this is an important piece of networking history in North Carolina, and of course there were some folks from UNC involved. The gentleman over there on the right is Steve Belvin, who actually was one of the people who wrote this software and went on to become a great leader in a number of areas, computer security and so on, written a number of books, spent a lot of time at AT&T. So he's one of those seeds that Oscar mentioned earlier, who came out of this project and went on to do great things. But so the conclusion of all of this is that, well, Duke invented peer-to-peer systems, right? Usenet in some sense really was the first peer-to-peer content sharing system, right? And it was the first system for decentralized large-scale content distribution. And it also was a very social system, right? This is a system that people get together and share information and views, and it builds communities, virtual communities. We heard a lot in the 90s about the netroots, right? That sort of came out of all of this. And I think we could also paraphrase Metcalfe's law in another way, which is that the flame wars that come, and everybody remembers flame wars, right? Anybody who spends time on the internet. So the flame wars grow exponentially with the size of the community that's linked by the network.
So this know who to blame.
Yeah, right, exactly. So this really was one of the things that's interesting about this is that it really was, in some sense, the application before the network, because these guys, they didn't have the internet. They were working with phone lines. Okay, this stuff initially ran over the phone. So these are innovators who had this idea, in some sense, a killer application for a network that didn't exist, and that in many ways sort of gives us a little bit of a preview of all the wonderful things that we could do with a network if we had it. And now Bob Metcalfe, the inventor of Ethernet, has now been invoked a couple of times, and so I'll do it again to mention Metcalfe's other law. Of course, he is known for his rule about the value of a network growing exponentially, as Tracy mentioned, and as we've heard. But he has another saying, which I really, invention is a flower, innovation is a weed. And it's one of those things that sounds really brilliant when you first hear it, and then you think, well, shoot, what does he mean by that, right? And it turned out he actually meant, with the innovation is a weed comment, that in fact, innovation in some respects is threatening, right? There are a lot of people who'd like to stamp it out because in some sense, innovation is threatening to established monopolies. And for that reason, actually, the community involvement and the government involvement and sponsorship of support for innovation is really very important to allow it to occur. So that's really what he said he meant when people asked him later. But when I first heard this quote, I really like the idea of innovation being a weed as something that innovation is going to happen against all obstacle, right? I like to think about the weeds that are growing up in the cracks in my driveway. They want to grow, they want to bloom, and so I think that's actually true. I think that's a good characterization of innovation. You have smart people, they come together, they're in a place, they have ideas, they're going to push to make those things happen. It's natural, and it's a wonderful thing. But then you ask, well, what could those people who are inventing the Usenet over phone lines, what could they do if they actually really had that investment, and if they had the kind of context where they could really innovate with state-of-the-art facilities that they could work with? And so, as been mentioned in this event now a number of times, I think North Carolina really is in a great place as a result, at least in part, of all of the investment that's happened here. When I came to North Carolina to join Duke almost 20 years ago now, I hadn't spent any time in North Carolina. I was on the West Coast. I grew up in the Northeast. But the investment that had happened here in the Research Triangle Park and the environment that had been created with the three universities definitely turned my head as a kind of place that seemed like it really could be up and coming as a hotbed of innovation in the future. And I think that's really, really borne out. So we've mentioned UNC and Duke. I want to say just in passing that, of course, there's a lot of great stuff going on here. I can tell stories about Duke, and I will, but there are these other universities here, not just UNC and NC State, but I'll just focus on NC State. We have other stories from these other universities, and if we look at some of the wonderful things that are going on at NC State, I've seen a lot of leadership in optical networking and in performance, understanding the performance of complex networks, but also In-Jong Ri there in the upper left is the author of designer of congestion control protocols that are running in millions of Linux systems all over the world. And in fact, a lot of those systems actually came from Red Hat, which is a company that was incubated right here in the Triangle. So there's a lot of wonderful stuff out there, and a lot of that does result from the investment that's been made here in North Carolina. And of course, when I came to Duke, it's a little bit scary for me to say, actually, that I'm the senior systems person at Duke right now. We had Carla Ellis, who's retired, but now we have this wonderful community of people, and these are some of the faculty in the larger networking area at Duke. Landon Cox is a leader in mobile social networking, privacy, mobile systems in the cloud together. Xiaowei Yang has been active in future internet architecture initiatives sponsored by NSF and is well known. Bruce Maggs is one of the founders of Akamai, which is the largest content distribution company. And Theo Benson will be joining us in the fall, and he is actually very well known for his work in software-defined networking and integration of software-defined networks with new kinds of networking as a service initiatives in the cloud space. So there's a lot of wonderful stuff going on at Duke, and obviously I don't have time to do justice to that. Glenn asked me to talk just a little bit about my own story, my own road to get to where we are now. And so I want to start with some initiatives we had back in the 90s to just start tinkering, get some stuff together and see what we could do with high-speed networks. And one of the things that we did was we started working with an experimental network called MiraNet and broke the gigabit per second barrier for TCP/IP communication between hosts in one room. But that was something that, Duke put out a press release and it sort of hit the news. And so this was sort of my first experience with lessons in public outreach. I talked to newspaper reporters for an hour and talked to them about this stuff, and then would see this little article that more or less completely garbled what it was that we had actually had issued clarifications on the net and so on. But it was a lot of fun, and it was a long time ago, as you can see from this picture, that BBC News chose to run with their article. But I think what's interesting about this is that their idea was, when I think, as Ilya mentioned, when you have this kind of capability, the natural question for people to ask is, what are you going to do with it? And sometimes it's hard to imagine what it is that you're going to do with it until you have it and until you expose it to the innovators and let people start thinking about that. Because I myself, in some level, I'm a glorified plumber. I really like thinking about the ways things connect and interact. And the applications are another story. So what they thought of was, okay, well, this is going to mean that we can watch movies like, what is this movie? I don't remember what this movie is. We can watch, that it says real-time, high-quality video will become routine. Okay, I suppose that's true. I'm a user of Netflix, but we knew actually that there was the story that we were really trying to move towards over time was that these really fast networks were about getting more and more computers to work together to provide larger and larger scale services to larger and larger communities of users. And that it was really the interaction and coordination of aggregates of computers, clusters, that was really what we were exploring at that time. And at that time, some of these clusters, people were using custom communication protocols. We really wanted to use standard internet protocols within the clusters. But we did a lot of work on the question of, well, if we're going to get lots of computers all pulling together in the same direction, how do we coordinate all of that? And so the question of how do we manage the resources within the cluster and allow that coordination to occur was an important focus. And what this slide is it's a picture from a paper that we did in more than 10 years ago now that was looking at some of the issues for dynamic resource management in hosting services, and also the question of how you can dynamically tweak the knobs in order to manage the energy that's consumed by clusters in proportion to load, which varies a lot in the internet and on these services. And we continued looking at that, thinking about the idea that, well, if you could have sensors distributed through a data center and have information about what's happening within these ensembles of computers and process that information in real time to make decisions about how to manage it, that you could actually manage this infrastructure in a much more efficient and effective way. And so the topic that we were exploring there was really the question of how would we manage heat flow in a data center. These data centers do generate a lot of heat, and that's an important energy consumer. So we wrote a number of papers that were on this question, what's now called green data centers. How do we actually improve the efficiency of these data centers? And along with that was the question of data centers or clusters or services that are actually serving multiple different kinds of uses, where new uses might be created, new services might be created, and then we could dynamically allocate resources for them and instantiate the service in that and grow and shrink it as needed in order to meet the demand for that particular service. So this is a paper from 2003. So now you know that Duke invented the cloud as well. Misnamed it. Well, at that time, you had to talk about the grid in order to get grants or get stuff like this published. In fact, it was a little bit of a challenge. But that was called Cluster on Demand, or COD. I understand that now COD